This is Drill PCB, your new PCB partner. Today we'll introduce several methods for rapid PCB layout in KiCad. Automatic layout has always been a frequently discussed topic in PCB design. Today let's take a look at how to achieve rapid PCB layout in KiCad. Once the schematic design is complete and synchronized to the PCB, the component footprints will be arranged together like this. This is what I've drawn, so you can compare it with theirs. What you just imported is this kind of layout, where all the components are arranged in order outside the board outline. Although they are neatly arranged, they are not grouped by functional modules, so this doesn't help much with the layout. Let's first take a look at how to use KiCad's built-in layout feature and see what the built-in layout looks like. First, we need to draw the outline of the PCB. Select the cut layer, then choose to draw a rectangle. Here, we'll use a rectangle as an example. Drawing a rectangle is a bit more convenient, so I'll just draw a rectangle and set its side. If you already have specific requirements for the PCB dimensions, then draw it according to those measurements. In my case, there are no special requirements, so I'll just draw a PCB outline that's roughly the right size. So how do we use it? Automatic layout. Here we need to place components. Under the placement menu, there's an option for automatic package placement. There are two options: place offboard packages and place selected packages. If we want to place all of them at once, we choose the first option, place offboard packages. Let's click it and see what happens. I can already see a progress bar. Since I don't have many components and my computer is fast, it placed them very quickly. The way it places the components is simply by arranging all of them in order. In reality, this doesn't mean much to us, because we still have to make adjustments here. It also doesn't arrange them according to functional areas. So, unless your design is very simple and has very few components, and you just need to do some minor tweaks after placement, this method isn't very useful. But for our case, where there are quite a few components, this approach doesn't make much sense. Then let's have it return to its original position first. As for the cross-probing function that we previously mentioned, we can effectively utilize it to meticulously place components module by module. This particular approach ensures that, at the very least, the individual components are systematically grouped together by their respective modules, which subsequently provides us with a truly significant and considerable advantage when it comes to performing manual debugging and making necessary adjustments later on in the process. Let's take our schematic as an example. In our schematic, there are several components on the top level schematic, and then there are two sub-schematics, each with an op-amp. Let's go into one of them and take a look. In this schematic, there are these op-amp components. Since these components are in the same sub-schematic, they definitely belong to the same module. For example, this is an op-amp module, and all the components are related. When we're doing the layout, we definitely want related components to be placed close to each other. So how do we achieve that? We select the entire module in the schematic, and then we go back to the PCB. At this point, we can see that the selected components, all the components in this area, belong to this group of op-amps. So what do we do next? Next we choose Place and then Auto Layout. Under Auto Layout, there's another option called Place Selected Packages. We can take a look. At this point, it will only move the components we've selected. So what's the advantage of this compared to moving everything over like before? It's placed according to modules. At the very least, I know that these components now all belong to the same module, which makes it much easier to adjust them later, because first we need to ensure that the local layout of this module on the PCB is complete. So I might move these connectors out first, then adjust the orientation of the op-amp, and then adjust the positions of the resistors and heat sinks. Let's assume that with these adjustments, the layout is now complete. Next, let's adjust the second module and bring it in. After bringing in the second module, we select it. It's the same as before. It also reuses this op-amp module. Once the second module is selected, let's take a look at the effect. See, this group of components is now selected. Now let's place this group in as well. It will be outside the current area because normally we arrange each module into a roughly regular square shape, occupying a certain position, so it will be placed in a different spot. In this way, we can efficiently bring in and lay out the modules part by part which will greatly improve our efficiency. Otherwise, you would have to refer to the schematic and then select the components from this side. For example, if you select an op-amp, you would need to check which arrows and which transistors are associated with this op-amp and pull them over one by one. This way, our automatic layout efficiency is greatly improved. We have introduced two commonly used methods for rapid PCB layout, among which the method that combines schematic and PCB cross-selection is the most efficient. I recommend that everyone use this method of modular automatic layout. Well, that's all for today's content. If you enjoyed this video, please subscribe to my channel for more videos. Thank you all.